The second type of Python loops is represented by the while loop. What is the difference between for and while loops, you might ask? Well, unlike a for loop, which executes a block of code a number of times, depending on the sequence it iterates on, a while loop executes as long as an user-specified condition is evaluated as true. If the specified condition does not change, meaning it doesn't become false, then the loop will continue executing forever, and we end up with an infinite loop. When the condition becomes false, Python continues to execute the code following the entire while loop. Now let's see an example of a while loop. First, let's define x equals 1. To create a while loop, you have to type the while keyword, followed by the condition you want to evaluate, and then a colon. Below, using tab for indentation, you specify the code to be executed as long as the condition is evaluated as true. So, let's say while x is less than or equal to 10, colon, tab, let's say print x, and x equals x plus 1. This means that after printing each x that is less than or equal to 10, we want to increment x by 1 and evaluate the next value. So Python takes the first value of x, which is 1, evaluates it against the condition as true, prints it to the screen, and then increments it by 1. Now, x being 2, it is again compared to 10, and the evaluation result is again true. Then it is printed out and incremented, and so on, until x reaches 10. When x reaches 10, the condition is still true because 10 is less than or equal to 10. Then the value is printed out and then incremented to 11. When evaluating 11 less than or equal to 10, Python returns false and exits the loop without printing or incrementing the value of x further. But what would happen if we don't specify the statement that increments x? Well, let's think. X is initially equal to 1. It is compared to 10, and the expression returns true. So it is passed to the code below. It is printed out on the screen, but this time there is no statement to increment it. So it keeps its value of 1, and it is again compared with 10. The condition being met again, it is passed to the code below, and so on, forever. Let's test this, because we'll end up with an infinite loop in the interpreter. You can use Ctrl plus C a few times to interrupt the loop. So, let's initialize x with a value of 1. Now, while x is less than or equal to 10, let's print x. As you can see, we are now in an infinite loop. To escape this loop, press Ctrl and C a few times, and now we are back in the interpreter. Another way to use while loops is by entering an expression which always evaluates as true, in order to make Python do something over and over again until you tell it to quit. A great example would be an interactive menu, where a user can select a value and enter a submenu, then return to the main menu, and so on. A frequent way to do this is simply by using while true, which takes care of the condition in the while loop, assuring it is always true. So this is the syntax: while true, colon, and then, I don't know, do something. Okay. We will see such an example after we'll discuss the break and continue statements. Now, one last thing on while loops is that we can use the else statement again, this time with a different meaning than before. The indented code below the else statement will be executed when the condition specified in the while statement becomes false. Let's see an example. So x equals 1, while x is less than or equal to 10. Let's say print x. X plus equals 1. Now the else statement. Else, a colon, print. Let's print out of the while loop. X is now greater than 10. Okay, so let's execute it. So using the same example as earlier, Python prints out x on the screen as long as it is less than or equal to 10. Then when x becomes 11 and the condition becomes false, the code below else is executed. Pretty cool, I think, and very useful too. Now, many times you will see for loops within other for loops. Same thing with if and while statements. You will also have to use if statements inside for loops or while loops, depending on what you are trying to achieve. Next, we're going to have a look at this kind of structures, which are called nested structures.